Hi, so I'm going to be talking about a few of the projects that were associated with the EDA grant. And Mark didn't mention that the EDA grant is also funding a 3-story version of the residential retrofit project. We originally intended to do a 2-story one, but that was when we thought we could actually do it inside the Emerson lab. But again, Andre and Ari, because the Ellie project is filling up the Emerson lab, we had to do it outside in the 104-degree heat and in the rain by the dumpster. So this is why literally it's next to the dumpster. You'll see that when you go out there. That's where the UO project is, right? So said this a few times, right? This is why we're waiting desperately because we actually have, after scraping together little bits of money over the years for our projects, we finally have a few $1 million from the EDA to really do prototype seriously. So Andre is working with us on the 3-story version, and also on testing a 2-story version of the 1-story one that we did outside. But this is actually a housing project we've been working on for some time. And by we, I mean, Mark and I have been leading it. We've been working with Jason on it, also with Professor Michael Gershfeld from Cal Poly Pomona, who many of you know. So as we know, we can use mass timber products and can compete very well on cost and efficiency in larger buildings for replacing steel and concrete. The question from my point of view has always been for a long time is whether we could actually get it to compete with light wood frame to make sturdier, more resilient, more fire resistant, smaller projects. And with MPP, certified in 2018, 2-inch, 3-inch sections, less fiber, it really seems possible. So we've been working on this project for quite some time. And we'd be looking at, first of all, as fully modular, like Pathhouse is doing. But under the influence of a number of people, mostly William Silva, who is here in the back, whose advice we always take, William. William was like, you should do it panelized, because we've been working with the city of Milwaukee for some time, and which has been changing their zoning code to comply with House Bill 2001 in Oregon, which has basically gotten rid of single family zoning in cities over 10,000. So they've been upzoning single family sites to accept cottage clusters of individual houses and duplexes. And so we've designed these quite small units out of MPP. This is the latest iteration. We've been through, 12 or 15 different site plans because the code and the interpretation of it changed. We went from singles to duplexes plus singles, to triplexes and quads, back to duplexes, and finally we're back, if I'm not mistaken, Mark, at singles, right? Because the code interpretation kept changing and we worked with them. It was a 2-year process, and we think this is probably the final form of it. We are working on, these are 3 of the sites. The 2 on the right are actually owned by Providence. We're kicking this into this project. And there's one other site a couple of blocks away. And what we're aiming for, these are 2-story, 2-bedroom units, 764 square foot. We're aiming at 80% area median income for essentially workforce housing, condo for sale, for home ownership. And we're working with Homework Development, which is an affordable housing developer. And we hope to have some prototypes done of these in a year or so. This is the plan. We've been working with MPP and panel sizes and working with an engineer. We think we can do the kind of side non-load bearing panels. The long ones are 2-inch. The end ones, floors and roof, are 3-inch, at least right now they are. And we'll see what happens once we finally get the alley out of there and we can actually put one of these houses on the floor, which will be a first step. That one is what Mark refers to as the Frankenstein version, where we try a lot of things to see what's most efficient. And then when we think we know what we're doing, we're going to build a second one outside using a contractor to figure out what it really costs, how much time it really takes, and if it keeps out water, and we're also going to do some thermal testing on it. So again, this is a project we've worked on for a long time. Mark and Jason are also looking at microgrids and a whole series of other ways of looking at these things to make them energy efficient. And again, we're panelizing everything, the inside, the outside. We hope, because we're doing digital prefabrication, and I say looking at Timber Lab, we hope we'll be working with you and not just William on this. We hope we can actually make it affordable. William has been working with us doing some costing, and it's looking pretty good. So we'll see. All right, so this is one of the ways we think we're getting to that price is that to make the, and it's not clear why I'm presenting this because this is really not my work. This is really Mark and Jason's, but somehow I'm doing it. And you'll see this out there also in the yard at Emerson. So in order to get to really, the DOE Zero Energy Ready Home Standard, so I wrote it down so I could remember what it is, you really kind of need to use triple pane windows, which are hellaciously expensive. So we've been looking at alternatives for doing this, and Mark and Jason came up with this idea of a sliding shutter, which could be the third panel. And you can see here that they're translucent panels. I feel like this was my sole contribution to this project, which saying it's like, if we make them solid plywood, it's going to be like you're in a coffin. So if you make them actually out of translucent material, some light will come through, and these insulated polycarb panels actually have insulating properties. So this is, these are some slides of the process, and you'll see it's very much like the retrofit. So we'll be using, the idea in the ADA project is that the port is aiming to construct a factory that will be doing completely modular, and we'll be doing panelized, which is what we're planning to do for the housing, where you prefab the panels, put on insulation and cladding, and then bring them to the site. And also the same process for the panelized retrofit. So we hope that the factory will be able to do all those different types. We think that the panelized one makes sense for ADUs, for individual houses, both in urban and rural settings, and for the retrofit, and for bigger buildings, the fully modular for larger buildings, we think makes a lot of sense. Anyway, you can see the process here again with seeing the panels and putting in the window and the waterproofing. You can see that the MPP had to be routed out for the handle. You can see Jason working on the window and trying to figure that out. Here you can see Phil posing very nicely in front of it, demonstrating the sliding window. And you can see that it slides pretty well. If you try it when you're there, you'll find it's a little noisy, right? It's kind of squeaks a little. So we're looking at how we're going to deal with that. And then they did some blower tests on it and discovered, among other things, that they're going to do another test once it gets colder outside. So you can look at the contrast much more. So this was actually a pretty successful test. And we're looking now, this is why, in fact, Mark just sent an email to somebody at Timber Lab to see if you could help us with costing what the, we obviously just had Phil and Mark do it in the lab, which is great, but we want to get some idea of what it would really cost to do the CNC and some other work to compare it to what it would cost to actually put in a triple pane window instead. Really, what is it? And this work was funded under an Energy Trust of Oregon fellowship that was given to our affordable housing developer Homework, who also got a couple of USDA wood innovation grants and has been giving us little bits of money, very little bits of money compared to what we just got from the EDA to try to work on this for the last couple of years. So I'm going to show you another project, which is going to look ridiculously familiar to you because it's about the 12th sign we showed in the alley today. It's like, I didn't realize until a few days ago I was talking about reuse, but Evan assigned it to me as well. So I thought I'd better. So, okay, so the alley project is, there's a lot of wood that's used in it. So one of the things we've been looking at is the idea of reuse and what you could do with it. So we started this last year, a new mass timber design focus within our 1-year Master of Science in Architecture degree. And I had 5 students start and finish, not only start, but they actually finished, graduated on time. And I gave them, a list of some potential projects. Some of them picked them, some of them didn't. And they did other interesting things. But Amanda Stanton decided that she would do this project that Andre has already talked about a little bit, and there's a poster in the back. But the idea was to look at what you could reuse from the alley. So Amanda took the Revit model and then the catalog of steel connectors and put those in the Revit model so she could figure out where they were and where very big ones were used. She knew that you would have to cut that out and you could not reuse that piece of the decking. So she did a catalog of how much you could reuse, and she showed it in the diagrams on the right, depending on whether you cut out thick pieces, thin pieces, but basically upcycling the decking to become columns and beams of various types. and showing how much volume you can get out of the alley. On the bottom, she showed the catalog of all the steel connections. So we had a good idea of how much volume you could use and the different ways you could cut it up and use it. And she used kind of conventional LVL beam sizes at the beginning because Freres had not yet come out with their beam and column design guide. They came out with it at the Mass Timber Conference, which was right at spring break, which was kind of great timing. So we actually used it in a couple of our MS projects right after that. So one of the impetus, the kind of inspirations for the project was that, being able to reuse it. And we desperately need, as you will see when you get to Emerson, a storage shed out back. So the idea was maybe we can, instead of buying timber, we could actually reuse the stuff from the alley. So this is a project that Amanda did with Phil Mann as client. And you can see that she chose to use the recycled LVL beams and some bracing. And she upcycled the MPP decking, which was 7 inches, into columns and beams. And I'm going to just show you a few images here. Here's where she actually shows you where it is in the alley and where it's transformed. And then again, where she used it as decking and what it's become. And also she managed to recycle the column caps. And she made a number of kind of, obviously there was a study and she made a number of conclusions from it. Obviously, and I think Andre already pointed this out, is that there's no finishes on here. It's not a composite slab. So it's much easier to think about reusing and recycling than it would be in, quote, a real building with all that stuff. But it's a start. And at least it gives some data about what you can use. One of the things she pointed out was that if you use what she called a stacking connection, I mean, instead of having beams and columns kind of meet each other, having and you could probably see it better if I just go back quickly. If you have, I don't even know how to use this equipment. Anyway, I have no idea how to use any of these things. If you look at the beam, which is overlapping and cantilevering out, her point was that if you use the existing lengths you had, even if it meant they were kind of overlapping, but even if you had a joint that was kind of stacking up, this allowed you more flexibility in reusing it another time because you haven't cut it to a specific length. So she made a number of conclusions about lots of things, the way you have to store the material, issues about shipping it, issues about cutting it out and what you lose each time. She actually calculated in the what you lose by cutting it up. It's about 1/4 inch of the saw blade. Yeah, I think that I just realized that Evan is telling me I have a minute, right? Yeah, just checking about that. And looking at what you reuse. So it's the beginning of a study and it's leading into the 10-story one that Andre was talking about. And Amanda's actually working on that now. She's working on assembling the same catalog of parts that she did for the alley. She's doing now for the 10-story one. And we're going to be looking for clients who want to use these pieces in various installations. This is a rendering. And the last thing I'll say, just a few words about the acoustic testing lab. This is a project that we've been trying to get going for a long time. We got a high-up grant from Business Oregon, which paid for doing a very detailed design development of the actual chamber. There's nothing really in the US like this, and certainly not on the West Coast. And there's no university in North America that has one. There's actually huge demand for these things. It's a floor testing chamber, which will allow floor testing of various kinds of mass timber floors and ceilings with various kinds of acoustic material. We actually sent it out for design bid. We got the University of Oregon and Board of Trustees to approve the project up to $8.75 million. We put it out for design bid and it came in as 14 million. And my provost believed that by putting it on pause, he actually thought he had effectively killed it. And then we got the EDA proposal and we suddenly realized that they do infrastructure and maybe we could get the acoustic lab and the fire testing lab out of it. And lo and behold, it did. And the last thing I'll say is the provost, who is now our interim president, sent us what started out as a very nice email congratulating us and getting, $14 million plus another about $18 million for the project. And then he said, now that you've caught the car, right? What are you going to do with it? So we know there's a lot of work ahead. I know that the University of Oregon is not always used to doing these projects, but we're very excited about it. And we know that a lot of people are excited about using it. And we think that this time we're very optimistic we'll come in budget because the budget is much bigger. And I know that a number of you are very interested in this project, perhaps in designing and building it. Thank you.